Hello and welcome to another episode of Mr. Walker's Chemistry. Today we're going to be covering electron configurations, and these are one of the things in chemistry that, quite frankly, can be memorized. But I'm gonna show you some tips and tricks that'll help make this a lot easier to do, and to help you understand, why we have these electron configurations. Okay, so today, by the end of the presentation, you should be able to find an element on the periodic table from its electron configuration. Each element has its own unique electron configuration. You should be able to find the electron configuration for any given element. And you should be able to tell me the number of electrons in an atom from its electron configuration. So quickly, just to review, last lesson you learned that electrons are in things called orbitals, developed by Erwin Schrödinger, that these orbitals have a shape of S, P, or D, and that there can be 1s, 3p, and 5d orbitals per principal quantum number, or per energy level. So within these orbitals, we learn that there's the Pauli exclusion principle, which says that you can either have no electrons in an orbital, 1 electron, or 2 electrons, but those are your only options. And so I have this little graphic here just to remind you guys of what we're talking about. Alright, so our nucleus is in the center. Remember that the nucleus contains protons and neutrons, and around the nucleus are the electrons in orbitals. So you start with the 1s orbital, then the 2s orbital, then the 2p orbitals, and then the 3s orbital. And they do fill out in this order. You want to fill out from low energy to high energy. There's no reason that an electron would typically start out at high energy. Okay, so we're gonna learn more about this as we go through the periodic table today. So, just a very brief introduction to the periodic table. We're gonna get really in depth on this thing, but today, just really quick, show you what it is, show you how we're going to use it for electrons. Okay, the periodic table is super useful. It's been organized in such a way that we can find almost anything about an element based solely on looking at it from the periodic table. It makes things really easy for chemists. Alright, so here's our periodic table. Pretty standard one here, okay? The symbol with the atomic number is on this one. That's all we need for our purposes today. And they're all arranged, numerically with these breaks. So we're going to kind of, why are these breaks here? What's the purpose of that? Well, let's look and see. Alright, so I've got a periodic table. Here's a periodic table that I've stripped the symbols and other information out. And what we have here is actually just the things we need for electron configurations and to find electrons. Okay? Now, some of these things will look similar. So we've got 1s, 2s, 3s, 4s, 5s, 6, and 7. Okay? So that is your principal quantum number. Notice that the principal quantum number is the same for S and P as the row number, or the period. Okay, rows are called periods on the periodic table. Alright, so S and P is the same here. We'll get more into this a little bit later, okay, why these drop a level. Alright, now then you have your blocks. Alright, so let me start adding some notes to this. So you can see we've got periods 1 through 7, which correspond with the energy level. Okay, the principal quantum number. So you could think of period equals principal quantum number. Alright, and then we have these blocks. So we have a block here, a block here, and a block over here. So we have the S block, the D block, and the P block. Now, you'll notice that helium over here is kind of like a little straggler. If it'll help you, you can think of helium as being in this little gap right here, okay? helium is over here because its properties fit with the same elements as those in this group here. But for electrons, it can go over here. It's hydrogen and helium are weird, and they never really kind of figure out where to put them on the periodic table. So sometimes you'll see hydrogen will be moved over here, sometimes helium's moved over here. They're kind of outliers, I guess. Regardless, these are the two really important things that you should know about a periodic table for electrons. You've got energy levels corresponding with periods, and you've got these blocks. S block is 2 rows, P block is 6 rows, and D block is 10 columns. So 2 columns, 6 columns, and 10 columns. Alright, now let's think back. Alright, pull up some information from what we know about the shapes. Alright, if I can only have one s orbital, so I've got one sphere per energy level, how many electrons can I have in the sphere? Hopefully you're saying you can have a maximum of 2 electrons in an s orbital because there's only one of them. Okay, guess what? We have 2 columns. So if I only have 1 electron in my s orbital, then I'm in this column. If I have 2 electrons in my s orbital, then I'm in this column. Alright, I'll say that again. Let me go back here, let me pull up this picture again. Alright, let me actually copy it over real quick so that we have it in this one here. Okay, if I'm looking at my atom, I've got a nucleus. Per each energy level, I can only have 1 s orbital. So if we're looking at the actual 1s orbital here, then it's the purple, and then if we go to 2s, we have a brown one, and they're both spheres, and then we have 3. Okay, so when we look at this, 1s is here, okay, 2s is here, it's further out, it's higher energy, 3s is way out here, so it's even further out, and it's higher energy. So we're increasing energy as we go down the periodic table. Now, we can only have one of these, so we have our 1s, then our 2s, then our 3s. And we're going to fill these up. So we're going to go 1s, we're going to put electrons in here. Then we're going to go 2s, put electrons in here. And then we're actually going to jump over here. So for now, you know, if you have 1 electron, then you're in 1s. That's hydrogen. If you have 2 electrons, then you're in helium, because you have 1 here and then 1 for helium. If you have 3, then you're here at lithium, and so on. Alright, so now let's apply that concept to the p block. How many p orbitals can you have? Well, let's count them. You can have 1, 2, or 3 p orbitals, the x, y, and z direction. Okay, so if we do that, then we have x, y, and z, because each of these can hold 2 electrons. Now, if you want to think of it this way, you can. Notice that there are 6 little bubble things, okay? 1, 2, 3, 4, 5, 6. There are 6 little bubble things, and you can think of it as each one of those little bubbles can hold 1 electron. So 1, 2, 3, 4, 5, 6, okay? Now this will take a lot of practice. It'll take time to get. Alright, and then same thing for D. There's not any D here, so I can't use the graphic, but remember that you can have up to 5 D orbitals, each containing a maximum of 2 electrons. That's where we get 10, 5 times 2, so that gives us 10. Alright, so we can start to see how this might be useful for finding an element. If I know that I have only 2 electrons in my element, then I can't go past this one, okay? We're going to learn how to start writing these. I just want to show you how this overlays really quick. Alright, so here I've overlaid the electron configuration periodic table with the regular periodic table. Okay, so we can start to see if I have 1s and we have 1 electron, then I have hydrogen. If I have 1s and I have 2 electrons, I have helium, and so on. Alright, so when I want to write something, let me show you how to write these. Okay. First always comes the principal quantum number. I am going to write the electron configuration for aluminum. Okay, so we're going to do aluminum, which is in the 3p block. So we should end with 3p if I do everything right. Okay, so let's start out. First thing you do with any sort of directions, remember we're trying to help people find elements on the periodic table, so think of it like directions. Start at the beginning. Okay, so my first thing is 1s. So 1s. Okay, that covers these. But how many electrons do I have? Okay, so I need to start filling in electrons. So I've got 1s. I need to go to the end of the block before I tell them to turn. So we're going to go to the end of the s block. So that means I have 2. Okay, 1s1, 1s2. Everybody see that? Okay, 1s, 1 electron, 1s, 2 electrons. So principal quantum number, shape, number of electrons. Okay, so some of you might ask, well, why didn't he write 1s1 then 1s2? Like, why do you go to the end of the block? It's just a shorthand. It's a way to keep it from being infinitely long when you start getting down to things like platinum. Okay, we don't want this thing to be going forever and ever and ever. Alright, so we're just going to shorthand it. We're only going to write the ones at the end of a block. So we're at the end of the S block, so we write 1. Now we need to go to the end of the 2s block. So we're going to do 2s. How many electrons do I have? 1, 2. So 2s2. Okay. Alright, now we've got this p block to do. We're going to jump over. Okay, so you just follow it in order, as it is in the periodic table. So 1s, 2s, 2p. So we know we need 2p, so we're going to write 2p. Alright, and now we need to find out, did we fill this whole thing in? Yes, because we're trying to get all the way down here, so we filled this in. How many can I have? Well, let's count them. 1, 2, 3, 4, 5, 6. Okay, so I can have 6. So 2p6. That's the end of our block there. So now we go to the end of the next block. So now we're at the end of the 3s block. So 3s. How many electrons? 1, 2. Okay. Alright, now we're getting there. We're almost there. So now we have to go to aluminum. Well, aluminum lives, so to speak, on the 3p block. But we're not going to the end of the block. We're only going to right here, because we don't care about these. We're trying to just get to aluminum. So how many do I have? Well, just 1. Okay, it's the very first one. So 3p1. So to recap how I got here. Okay, it's like giving directions to somebody. I'm going to say, if I want to go from Chesapeake High School to my house, I'm going to say that you need to go to the end of the road at Chesapeake High School. Then you need to turn onto Mountain Road and go to the end of Mountain Road. Then you need to turn on to 100, go to the end of 100. Okay, so on and on and on. It's kind of like that with the periodic table. Okay, get on First Street, go to the end of the street. Get on Second Street, go to the end of the street. Get on this 2p street, go to the end of the street. And that's what we're doing here. Okay, so to get to aluminum, I started here. This is my start line. Okay, so always start right here. So we're going to go start 1s. Then we need to go to the end of the block, so we count them. 1, 2, 1s2. Go to the next block, which is 2s. Okay, 2s2, because there are 2 of them, and so on. Let's practice with another one. Okay, so let me clear all this off of here. Okay, remember, we're always going to start right here. Let's do oxygen. Okay, this one's a little easier. Alright, so we're going to do oxygen. First thing is go to the end of the first block. Okay. Next, we're going to go to the end of this block, and finally, we're going to end because we don't need to go to the end of this block. O lives on 2p. Alright, so 1s2, 2s2, 2p, 1, 2, 3, 4, 2p4. Okay, one more, then we'll get to some real practice for you guys to try. All right, let's do neon. Okay, so neon lives at the end of 2p. So we're going to go to the end of the first block, end of the second block, end of that one. So 1s, 2, okay, 1, 2, 2s, 2, 1, 2, 2p, 6. 1, 2, 3, 4, 5, 6. Okay? Alright, so now for some real practice. Let's see what you guys can do. Alright. I've actually already given you this one, so try some of these other ones. Also, if I give you the electron configuration, can you tell me which element it is by following the same idea, the same strategy? Okay? I give you one of the harder ones here. I tell you to go down to the 3D block. Okay, I think that you can do that. Use the overlay here. Alright? Use the overlay to help you out. And then, how many electrons are in each of these atoms? Well, how do we figure out how many electrons we have? Well, just count them up. Okay? Count them up. For example, with this electron configuration, I have 2 electrons, 2 electrons, 6 electrons. So this one has 10 electrons, whatever element that is. Okay? For this one has 3 electrons, 2 plus 1. That's how you figure out how many electrons you have. Very simple. So quickly to recap, you've got the 3 shapes, S, P, and D. They are arranged on the periodic table to make it easy to find them, and you can use these to create addresses, also known as electron configurations, to figure out where your electrons are in an atom. Alright, I hope you learned something. If you're not getting this first time through, please, as always, rewind and try again. Be sure to ask questions in class, okay? So I'll see you next time.